Let's graph this quadratic function by using key features. So we have f of x equals x squared plus 2x minus 6. And our first step is we want to find the axis of symmetry. To find the axis of symmetry, you use the formula x equals negative b over 2a. In this case, b is 2 and a is 1, because anytime there's nothing in front of our variable, there's that imaginary 1. So we plug that in. So negative 2 over 2 times 1. 2 times 1 is 2. 2 over 2 is 1. So negative 1 is where our axis of symmetry is. Step 2 is to find the vertex. To find the vertex and determine whether it's a maximum or minimum, use the value you found for the axis of symmetry as the x-coordinate of the vertex. Find the y-coordinate using the original equation. So anywhere you see an x, because remember we said that x was equal to negative 1, wherever we see an x, we're going to change it to negative 1. Then we'll use our order of operations to simplify and get negative 7. So the vertex lies at negative 1, negative 7. Because a is positive, the graph opens up, so the vertex is the minimum. I sat here too long and my lights went out. Step 3, find the y-intercept. So the y-intercept is where it crosses the y-axis, so that means that your x is 0. So go ahead and put 0 in for x anywhere you see it in the equation. Use your order of operations, simplify it down, and you get negative 6. So we know that the y-intercept is at negative 6. Step 4, find additional points. You can choose any numbers that you want to put in for x. The smaller, easier to work with numbers are better, but you certainly can put in a big, huge number if you want. They chose 2 here, so they put 2 in everywhere that they see an x, used their order of operations, simplified it down, and got 2. And use the axis of symmetry to find the corresponding point on the other side of your parabola. So I'm going to play this little video for you here so you can see that in action. Okay. So they have their y-intercept here at negative 6 and our vertex and the 0.22 that we found. So you connect all of those and you know that there has to be a corresponding point on the other side of the axis of symmetry for this negative 6. So that means there's a point there, and there has to be a corresponding point for this positive 2 here on the other side. So it ends up being at negative 4. And the last step is to connect the points. Use a smooth curve to connect the points. When locating points that are on opposite sides of the axis of symmetry, not only are the points equidistant from the axis of symmetry, they are also equidistant from the vertex. Okay, so this is at negative 1, right? So we know that this is 1 spot away, this point here. So we know that the opposite one has to be 1 spot away as well. This one is 1, 2, 3 spots away. So we know that the mirrored image of it has to be 1, 2, 3 spots away. They're equidistant from the axis of symmetry, and they are also equidistant from the vertex.